All right, guys, welcome back. So we're now talking about how to graph from standard form. Remember that solving standard form required us to use the quadratic formula, so we know now how to at least find the x-intercepts or the solutions for our equation. Now we need to talk about the rest. So how do we find our vertex and axis of symmetry? How do we find our y-intercept, and what does our graph look like? So let's talk about those steps. So step number one, we're going to solve for the x-intercepts, graphing both. So again, that's where you are using the quadratic formula. So step number one, use the quadratic formula, find your solutions. Step number two, find and plot the vertex and axis of symmetry. It tells us that the x value is x is equal to the opposite of b over 2a. So unlike in both factored and vertex form, we've actually got a formula also to use for our x value. Notice that that is actually negative b over 2a, the very first part of the quadratic formula right here. So that is basically what you have before you add and subtract the discriminant from it. So let's go ahead and do that. Practice real quick. We've got f of x is equal to 2x squared minus 5x minus 3. So you've got a is 2, b is negative 5, and c is negative 3. So putting those in, we're going to have that x is equal to the opposite of b. So opposite of negative 5 is positive 5 over 2 multiplied by a. So 2 multiplied by 2. So that's going to become 5 over 4. And then you could convert that to a decimal in order to graph it. Now, that's only the x value. So remember, to get the y value for vertex, you're then going to have to put that back into your equation and simplify. So this is going to look like this right here. 5 over 4 goes in for x. And then I would just recommend using a calculator to simplify everything. And then keeping it as a fraction, unless it tells you the decimals are okay. And so as a fraction, that becomes negative 49 over 8. So then there would be the y value for your vertex. So you would have, as a point, 5 over 4, comma negative 49 over 8. Next, for step 3, we're going to find our y-intercept, which is just our c value, and reflect over the axis of symmetry. So let's talk about that. Why is it our c value? Well, remember y-intercept, you're putting in 0 for x. So if we do that, 2 multiplied by 0 squared minus 5 multiplied by 0 minus 3. Well, anything that's being multiplied by 0, so your first term and your second term are just going to be 0. That really just leaves you with the c value, your constant, as your y-intercept. So that is one nice part about graphing in standard form, is that the y-intercept is going to be pretty easy to find. Once you've done that, we'll reflect it over our axis symmetry and then connect our points to make our graph. So the harder part about graphing in standard form, as you might see, obviously quadratic formula, finding the x-intercepts, is going to be one of the harder parts to do. The other part is the vertex. The vertex is going to be probably the hardest thing about standard form in order to graph. Okay, so let's do a few examples of this just to make sure it all makes sense and kind of how it works. So number 8, we've got f of x is equal to 2x squared minus 4x minus 8. Let's go ahead and start by finding our x-intercepts, which, just like in the other sections, we have already solved number 8, 2x squared minus 4x minus 8, was actually number 1 from the previous page. So we have 1 plus and minus the square root of 5 as our two solutions that we will use. Let's go ahead and write those in as our x-intercepts. So one of them as 1 plus the square root of 5, comma 0. The other is 1 minus the square root of 5, comma 0. Now obviously, to graph those, let's go ahead and find some decimal approximations just to make those a little bit easier to graph. If we take 1 plus the square root of 5, that is 3.24 to the 100th place. So 3.24 comma 0. The other, if we take 1 minus the square root of 5, is negative 1.24 comma 0. All right, so let's go ahead and graph each of those. So 3.24 comma 0 is going to be a little bit past x equals 3. Negative 1.24 comma 0, a little bit past negative 1. Okay, step number 2, find and plot the vertex and axis of symmetry. Okay, So we're told that the x value is x is equal to negative b over 2a. So let's go ahead and relabel our equation. So a is 2, b is negative 4, c is negative 8. So then x is equal to the opposite of b. So opposite of negative 4 is positive 4 over 2 multiplied by a. So that's 2 multiplied by 2. So that becomes 4 over 4. And actually that works out nicely because x is going to be a whole number. So x is going to be equal to 1. So there's the x value for our vertex. That also is our axis of symmetry. Okay, so let's find the y value for our vertex. We need to put 1 back into our equation. So 2 multiplied by 1 squared minus 4 multiplied by 1 minus 8, which is going to become 2 minus 4 minus 8. 2 minus 4 is negative 2. Minus 8 is negative 10. So there's the y value for our vertex. So let's go ahead and graph both axis of symmetry and vertex now. So axis of symmetry we found was through x equals 1. And then our y value for our vertex was at 1 comma negative 10. So the very bottom of our graph here. Last thing that we need to find in order to complete our graph is our y-intercept. Remember that that is just your c value, so that would just be 0 comma negative 8. So then we can go ahead and graph that as well, 0 comma negative 8, which would be right here. And then we'll reflect that over our axis of symmetry, would be this point right here. And now we've got all 5 points that we need to create our graph. Something that looks something kind of like this. All right, so let's fill in the rest of the information now that we've got our graph. So which direction it opens. This one opens up. As far as max or min, that tells us it's going to be a minimum. So then our minimum value is going to be at the y value for our vertex, which is at negative 10. Domain, just like every other problem, is going to be all real numbers. For the range then, we're going to have everything above negative 10. So y would need to be greater than or equal to negative 10. And for number of real solutions, remember that we had 1 plus and minus to the square root of 5. Those are real solutions, so we're going to have 2. Notice that that's asking for number of real solutions, not for the number of complex solutions. So when we do have complex solutions, we're going to write 0 for the number of real solutions on those types of problems. All right, let's take a look at another example. So on number 9, we've got that g of x is equal to x squared plus 4x plus 6. Once again, we've already solved this, so we already know what our x-intercepts are. So on this one, this was actually number 3 that we had solved before. So we have negative 2 plus and minus I square root of 2. Now obviously those are not real numbers, so for number of x-intercepts, we can actually write that there are going to be none. So for number of real solutions, like I was just mentioning, we're going to put that there are 0. So let's find the rest of the information that we can use to help us graph. Let's start by finding our vertex. So for our vertex, an axis of symmetry, x is equal to opposite of b. Let's go ahead and label our numbers. So a is 1, b is 4, c is 6. So opposite of 4 is negative 4 over 2a, so 2 multiplied by 1. So that becomes negative 4 over 2, which again works out kind of nicely, gives us that x is equal to negative 2. So that's going to be x value for our vertex as well as our axis of symmetry. All right, so now let's go ahead and find the y value for our vertex. So we'll take negative 2, put that back in for x in our original equation. So that'll look like this. Then we'll simplify that, so that becomes negative 4 minus 8 plus 6. And let me go ahead and correct myself, positive 4. Negative 2 squared would be positive 4. So then 4 minus 8 is negative 4, plus 6 is positive 2. So our y value for our vertex is going to be at positive 2. Let's go ahead and graph both axis symmetry and vertex then. So axis of symmetry, again, is through x equals negative 2. And our vertex is at positive 2. So really the only other thing that we can find in this case is going to be our vertex, which vertex, remember, is just the c value for your function. So 0 comma 6 would be your axis or your y-intercept. So that's going to be this point right here. And we'll go ahead and reflect that over our axis of symmetry. And so in this case, rather than having 5 points to graph, we're just going to do it with 3. And again, that's because our x-intercepts are not real numbers. And it should make sense too why that's the case, because looking at our graph, clearly it does not cross our x-axis, so it should make sense that there are no x-intercepts. So let's go ahead and fill in the rest of this information. Obviously, our graph opens up in this case and has a minimum. So for our maximum value, our minimum value is going to be at our y value for our vertex, which is 2. Once again, domain is all real numbers. Lastly, for our range, we're going to have all of our y values that are above 2. So y is greater than or equal to positive 2. All right, let's take a look at one last example, and then that'll be it for graphing in standard form. So for number 10, we've got h of x is equal to 3x squared minus 6x plus 6. Let's go ahead and see what those solutions were. So 3x squared minus 6x plus 6 was actually number 4. So our solutions are 1 plus and minus I. So once again, since those are complex solutions for x-intercepts, we're going to say that there are none of those. And so for number of real solutions, once again, we're going to put 0. All right, so let's go ahead and find our axis of symmetry and x value for our vertex. So we're going to have a is 3, b is negative 6, and c is positive 6. So we're going to say x is equal to the opposite of b, opposite of negative 6 is positive 6, all over 2a, so 2 multiplied by 3. So that's going to become 6 over 6, and so the x value is going to be 1. All right, so let's now plug that back into our original equation, see what that gives us for the y value for our vertex. So here's what that looks like. 3 multiplied by 1 squared is 3, minus 6 plus 6, and that's going to simplify to just be 3. So let's go ahead and graph both of those. So axis of symmetry is 3x equals 1, and our vertex is at 1, 3. Next, we'll go ahead and graph our y-intercept. So remember that that is 0, c. So in this case, that is 0, 6. So that's going to be this point right here. We'll go ahead and reflect that over our axis of symmetry. And here would be our graph through those points. So once again, should make sense why there is no x-intercepts. Obviously, it does not cross our x-axis. All right, so let's go ahead and fill in the rest of this information. So which direction it opens. This graph opens up. As far as max or min, this is going to have a minimum then. Our minimum value then, we're going to say is the y value for our vertex, which is at 3. Our domain, one last time, is all real numbers. So for our range, that's going to be everything above that minimum value of 3. So y is greater than or equal to 3. All right, guys, that is it for this section of notes. Until next time, have a great rest of your day.